If your child is considering something as big as joining the military, you can bet they're taking the time to do some research. You can too by visiting todaysmilitary.com, because their success tomorrow begins with your support today.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on Space Nuts, the podcast dedicated to learning as much as we can about life, the universe, and everything, and astronomy in general. And joining me, as always, is astronomer Fred Watson. Hello, Fred.
Hey, how are you doing, Andrew?
I am well. How are you?
I'm rejoicing in the news that you and I will be talking about very soon.
Oh, yes. It's a
Big
huge story, and I'm guessing most of our audience has already picked up on this through regular news channels, but it is very, very exciting. Of course, we're talking about the discovery of liquid water on Mars, or under the surface, to be more precise. We're also going to look at the missing moon balloon, and it's not what you think. And we've got a really fascinating question about why satellites fall back to Earth or get burned up in the atmosphere. We'll explain that. We've been over that ground a couple of times before, but it's very interesting stuff and well worth revisiting. But Fred, this news of Mars has just got the whole world, the astronomical world, chattering, and even mainstream media has sort of gone, oh, hello, there must be life.
Yes, that's right.
What's happened here? What have they found?
So this is work that has been published by Italian scientists, in fact, who've used an instrument called MARSIS, or MARSIS, depending on how you pronounce it, which is an acronym, of course, for the Mars Advanced Radar for Subsurface and Ionosphere Sounding.
Good.
MARSIS sounds a lot better.
It does.
And it's on the Mars Express spacecraft, which is a European spacecraft. So basically, it's a radar instrument that looks down at the planet's surface. It has provided the most detailed maps of Mars's surface because it gives very accurate measurements of the height of the landscape that it flies over. But what has been done now is that the particular scientists who've done this work have looked very closely at the southern polar ice cap of Mars. Mars is like the Earth. It's got polar ice caps. They're a mixture of carbon dioxide ice and water ice. Ours are purely water ice, of course. We're too warm for carbon dioxide ice to form. But those ice caps are of great interest. So what the scientists have done is looked in great detail at the radar reflections that have come back from this region of Mars over many passes by the satellite, because the satellite, goes over this region periodically and lets you make your measurements. And what they found, and it's taken them a few years to actually analyze these data because the observations were taken between 2012 and 2015. What they found is a really bright radar reflection, basically from the bottom of the ice layer. So they get a radar reflection from the ice layer and a radar reflection from the rock at the bottom, which is 1.5 kilometers below the top of the layer of ice. But there's a couple of places where they get this really bright reflection at the base of the ice cap, and it's brighter than the rock reflection. And what that tells them, because there's only one possibility for that, is that there is a water interface there. So there's liquid water at the bottom of the ice. Now, we don't know how thick it is because the radar measurements are not yet sufficiently fine resolution to be able to determine, the difference between the bottom of the the bottom of the liquid water and the top. But my guess is it's of the order of 100 meters thick, something like that. But it extends for about 20 kilometers.
That's big. That's a big lake.
It's a big lake, and it's underneath the ice of Mars. In many ways, it's not a surprise. In fact, it was sort of predicted over 30 years ago that we would find these things. That was long before Mars Express or any similar spacecraft had visited Mars. And of course, there is a precedent here on Earth because Lake Vostok in Antarctica is exactly like this. It's under a rather deeper layer of ice. I think it's about 4.8 kilometers thick, the layer of ice in the Antarctic ice sheet. This is only 1.5 kilometers thick, but the phenomenon is the same. You've got basically a large body of liquid water underneath the ice.
Now, people will be saying, okay, if there's water under the ice, why isn't it frozen? Which is a pretty, it's an obvious question, but there's got to be a reason.
There is indeed. Well, there has to be, yeah.
Yeah, well, that's duh.
So you're quite right. The temperature at the bottom of this ice cap, where the ice sits on the rock, is estimated to be, wait for it, minus 68 degrees Celsius.
Ooh.
Now, you and I know that that's way, way below the freezing point of water.
I've measured my wife's body temperature at that when she's in a really bad mood.
I'm not going to go there, Andrew. In fact, I'll leave that one completely alone.
I thought you would.
So you've got to look at what is actually causing the depressed freezing point. And there are two things. One is the pressure of the ice above it. We know that when a layer of ice above a surface like the bedrock, that actually the pressure of the ice itself causes a depression or a lowering of the freezing point of water.
You can do that experiment at home with an ice cube, can't you? You can just put an ice cube down, put some pressure on it, and it starts to liquefy.
It starts melting. Exactly. Yeah. That's for exactly that reason. That's right. And it is probably that mechanism that helps to keep the Antarctic, the terrestrial, the things on Earth, the lakes on Earth, liquid, because there's 4.8 kilometers of ice, which weighs a lot. Yeah. Every cubic meter weighs a ton. So it's, it's pretty hefty pressure that's on top of it. And that is certainly helping to keep that water liquid. However, on Mars, you've only got 1.5 kilometers. You've only got 1/3 of the gravity. So you don't have the same pressure. So there must be something else keeping it liquid. And we believe that is due to the presence of dissolved salts in the water, in particular sodium, magnesium, calcium, all of which have been found on the surface of Mars, and in fact have already been cited as being a kind of natural antifreeze that in some circumstances allows you to see liquid water on the surface of Mars. Only small droplets, but it has been observed there because of this natural antifreeze. They can reduce the melting point of water down to minus 74 Celsius.
Wow. So
if you've got these salts in that water, then the freezing point is lower than the temperature, the ambient temperature being minus 68. So that is, a pretty cogent explanation for why this is still liquid.
Now, the $64,000 question is, could this body of water harbour life? Now, from what I've read, for life to exist, you need water, you need nutrients, and you need energy. And on Earth, we have those things, and voila, we have life. Mars is a little bit of a different story, but could there be life there? Is there a sniffle of a chance?
I think there is a sniffle of a chance, but to be honest, and I don't want to sound like a killjoy here.
No, please do. We've got to be honest. We've got to be honest and upfront.
Honest and
integrity is required.
There is there's a factor that might argue against that, and that is exactly what we've just been talking about. This extreme salinity of the water is basically brine. It's really strong brine, and some astrobiologists have speculated that the concentrations of these mineral salts are such that they would not allow any microbial organisms to survive. They wouldn't be, microbes wouldn't be tolerant of it. Now, we simply don't know the answer to that. We know that on Earth, microbes exist in all kinds of different conditions. Some like water above above boiling point. Some like water below freezing point. Can microbes survive in a really heavily loaded briny liquid? We don't know the answer, but it does kind of argue to some extent against this being a hotbed of life. On the other hand, of course, there is brine in the oceans of the world, and you and I have both noticed that they're quite full of life, really.
Yes, absolutely true. And has that taken the attention away from some of the ice moons that further out in our solar system? Because they were certainly seen as potential life candidates.
Yeah, that's right. Look, it doesn't take attention away from them. In fact, in many ways, it's a similar situation. On those ice moons, you've got a layer of ice much thicker than this one. You've got liquid water underneath it, but these are global oceans of liquid water. They're not just, not just the sort of 20 kilometers of lake water that we're finding here on Mars. But yeah, there are definitely analogues between the two.
And finally, one of the other things that's been brought up in regard to this is that when we ultimately send people to Mars, we're going to need to be able to find a way to, survive, and water is essential. Is this potentially a water source that they could use?
It is, but there are probably easier ones to find, because we know that, in the northern, certainly in the northern Arctic of Mars, where the Phoenix lander landed in 2008, actually. I was thinking it's 2012, but it wasn't. It was before that. That lander sampled the subsurface soil, and only a few millimeters below the surface, there is liquid water. I beg your pardon, there's frozen water. It's a permafrost of water ice. So that's a lot easier to get than stuff buried deep down underneath an ice cap.
Yeah, I would imagine it's a lot easier to sort of get something that's frozen near the surface and melt it and purify it than it is to dig down 1.5 kilometres.
Exactly, yeah. And the other thing is, well, we might want to send robotic drills down to have a look at what's in there. But then you've got all these ethical questions that you and I have spoken about before.
Yep.
In fact, terrestrial microbes, we know, are pretty hardy things. They take free rides on spacecraft all over the solar system. No matter how well they're sterilized, there are still a few remaining living organisms on them. Do we want to pollute the potentially pristine environment beneath the ice of Mars? We don't know that yet.
It's a dilemma, because we want to learn, but
we do want to learn. That's right.
In doing so, we could expose a risk. We could create a risk, and where do you draw the line? But it's a fascinating discovery, and one that obviously is going to be talked about for a long time and studied more and more. And what else could we learn from it is the big question, I suppose.
Absolutely. This is just the start, because what will happen next, I'm sure, is that we'll have higher resolution radar systems. There are spacecraft which are planned to reach Mars in 2020 with orbiting components to them. Higher resolution might give us an idea how thick this water layer is. And in fact, you might be able to devise experiments that tell you a little bit about the contents of the water, although there's really nothing like going and drilling holes to find out what it's like.
Stick a tap in it and turn it on and see what comes out.
I think just on that subject, though, Andrew, in many ways, the easier job to do to sample water underneath the ice is to go to Enceladus, the moon of Saturn, where you've got free samples being squirted out from the sun. And if you can fly a spacecraft with the right equipment on board, which Cassini didn't have, to sample the possibilities of lipids and proteins and things of that sort, amino acids in those jets of ice coming from Enceladus' South Pole, that might tell you much more about the ocean underneath that ice without having to start drilling holes and things of that sort.
And of course, there's one more thing. If by chance they do find life in this brine on Mars, let's say we do go there and we do test it and we go, oh, there's life. The DNA will be the interesting factor. Because if it's the same as life on Earth, then we know that the planets have been talking to each other and perhaps making love. But they're that answers a huge question in life on Earth and beyond.
It's the question is, is there one single origin of life in the solar system, or were there multiple ones? And that's a question we do not have the answer to, and it's a very interesting one.
And all we have to do is find life somewhere else and test the DNA.
That's right, exactly. That's all we have to do.
Simple.
But the bottom line is, if there are, if you do that and you find that you can put down life on Mars to a completely different origin from life on Earth, then the assumption must be that life is fairly common throughout the universe, because if it can do it twice in the solar system, it will do it elsewhere.
Yeah, it changes the whole game, doesn't it?
That's right. It does,
so we're not quite there yet, but we will soon be able to answer David Bowie's question, is there life on Mars?
Maybe.
And more to come on this, I am sure. This is Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Okay, Fred, next, the missing moon balloon. Now, people are going to go, did we send a balloon to the moon and it's floated away because of the low gravity and we'll never get it back? No, we didn't. And no, it's got nothing to do with sending something to the moon, has it, Fred?
No, not really. It's an artwork, Andrew. This is really, in some ways, the sublime to the ridiculous, but I'm a great fan of artwork, so I'm not calling it ridiculous. I'm just saying it's a great shame that it's got lost in the post.
And that's what's happened. It's as simple as that.
It's a 7-meter diameter, and for listeners who don't do meters, it's 23 feet in diameter.
They don't use the pathetic system.
That's right. And it's a moon, so it's a balloon basically, but it's covered with essentially a very accurate map of the moon, which is based on NASA observations, probably I would guess from Lunar Reconnaissance Orbiter, which is the NASA spacecraft currently in orbit around the moon and mapping the surface very accurately. It's sent back pictures of all the features on the moon, including those 6 lunar module bases that are still sitting there. So there is an artist who comes from Bristol in the United Kingdom. His name is Luke Jerram, and he has created this image of the moon, this giant sphere of detail of the lunar surface. And he's shown it at various different festivals and things of that sort. It's had a pretty good outing in terms of its venues in the United Kingdom. But he's sent it off to a festival in Vienna, in Austria, and it's got lost in the post. And
I shouldn't laugh. But how do you lose something that's 23 feet wide?
well, you see, he's probably packed down to something the size of a suitcase, and
Yeah, probably.
just a big parcel. And he's very upset, as I would be too, I think. He's sort of a bit. There's a tweet from him. He's, saying it's got lost. How is this possible? He's got a quote saying, it has huge implications for all these people who are looking forward to seeing this artwork, and they won't be able to, as it's in some warehouse somewhere. We haven't got a spare. I hope TNT pull their finger out and try to find it.
Well, it wouldn't have been easy to make, and to do it as accurately as he has, and I believe it's done to scale. I think each centimetre is equivalent to 5 kilometres or something, which is just extraordinary. So the detail must be amazing.
Yeah, it looks fantastic. The pictures I've seen, it looks sensational. And I think I'd be a bit upset as well. Of course, it is possible that by the time our podcast listeners listen to this, it may have been found, and I might express the hope that it has been and that this news story disappears altogether.
I think I know what happened, Fred.
Okay, right.
Well, the postal workers looked at that and said, they're sending this to the moon. They haven't got enough postage. So they just put it in the back cupboard until somebody comes up with the money.
Somebody coughs it up. Yeah, that's
what it is.
As easy as that. That's right.
Oh, dear. Well, these things are sent to try us, and this is obviously one of those things that, it's good for astronomy that people are wanting to create these kinds of images, and when it appears at festivals and events, people would be captivated by it. And I'm sure someone sort of says, well, that is where Apollo 11 landed.
Yeah, that's right. Yeah.
That's the Sea of Tranquility, and that's what happened. And that being able to see it on a very large scale rather than a photo in a book makes all the difference, I imagine.
Look, that's right. It's, when this thing's in front of you in all its detail, I think it would be very, very imposing. Apparently, Luke Jerram's also made a similar version of the Earth, replica of the Earth, which will be worth seeing as well.
Yeah. Well, I hope he does Mars, because it's just geographically incredible.
Yes, it is. That's right. Absolutely.
All right. Well, hopefully it'll turn up. Maybe at my place. I'd love for it to be redirected accidentally to my house, but unlikely.
Give it back, though,
But I can't wait to see where it surfaces. You're listening to Space Nuts. Andrew Dunkley here, and Fred Watson there.
Roger, you're loud and clear here also.
Space Nuts.
Finally, Fred, we are going to, strangely enough, answer an audience question. This one comes from Judd Brown. It appears from the email that he's sent to us, or the message via Facebook, that he has met you, Fred, and he still wants to talk to you. Anyway, he's enjoyed chatting to you at the Sydney Observatory at some stage. Thanks for the question, Judd. I've never studied physics, but I've been told that the satellites we launch into orbit are in a nearly perpetual state of falling back to Earth, but they stay in orbit for some time because their velocity creates a balance between gravity pulling them down and centrifugal force pulling them outwards. Why do man-made satellites eventually fall back to Earth, and yet moons and planets stay in orbit perpetually, or do they? Thanks for your knowledge and enthusiasm. Thank you, Judd. The answer to the question is, Fred?
Yes.
Yeah, and thank you for joining us. We'll be back next week. There's more to it than that.
It is. It's a great question. And what Judd said is actually correct. It's one way of looking at it, that there's this balance. I always prefer to think of it as the fact that if you've got a spacecraft in orbit around the Earth, it has to stay in orbit. It has to have a very high horizontal velocity. In other words, a velocity parallel to the Earth's surface. And in fact, that velocity is basically the velocity for an object at 100 or 200 kilometers above the surface is about 7.8 kilometers per second. At that speed, and you can work this out, at that speed, the forward motion is such that as the object falls back towards the center of the Earth's curvature is falling away at the same rate. And so the thing just keeps on going round. And there's actually a diagram in Newton's Principia, published in 1687, that shows exactly that. It shows a cannonball being fired from a mountaintop. And, if you don't put enough gunpowder in, the thing just falls back to Earth. But if you put enough stuff in it, it will keep on going around the Earth, because the Earth is falling away at the same rate as your spacecraft is falling towards it. Now,
the downside of his theory is that at ground level, there are other things that would influence that.
That's right, yes. There's other stuff in the way.
Trees, for example. But I know where he's coming from.
Yeah. So, look, you need to get probably the lowest viable satellite orbit would be of order 100 kilometers above the Earth's surface. Now, at that height, you're above a very large percentage of the atmosphere, but you're not above all of it. And in fact, the drag of the atmosphere on your object traveling at 7.8 kilometers per second would very quickly slow it down. And as it slows down, it basically wants to go into a lower orbit, and then it slows down even more, and then it goes into a still lower orbit. And of course, that's what we call re-entry. It winds up usually burning up in the atmosphere, because you're still traveling very, very quickly, and the friction with the atmosphere burns it up. However, if you go to a much greater height, and for example, 36,000 kilometers, and I'm not just pulling that figure out of the air, that's the distance from the Earth's surface that a satellite goes around the Earth once in 24 hours. And so it's where all the geostationary satellites are, the ones that we use to send signals around. In fact, for many of our podcast listeners, we're probably coming, you and I are probably coming to them via a geostationary satellite as we speak.
Indeed.
Which makes you wonder why people don't do more serious things with these. Anyway, never mind.
Well, I mean, the most serious thing you can do with a GPS system is plot the distance of a golf shot. I mean, I can't see any other purpose.
Yes, of course. Well, we won't go there either. But so at 36,000 kilometers, there basically is no air left. The atmosphere has dwindled to zero. So there's nothing to slow down these spacecraft. So they stay there. And in fact, at that orbital distance, there is a lot of stuff that's been up there for 40 odd years. There are new rules and regulations now, Andrew, that say that if you're going to put a spacecraft into a geostationary orbit, 36,000 kilometers above the Earth, you have to equip the spacecraft with the means to put it in what's called a graveyard orbit. And this is actually pushing it further out slightly, so it's never going to collide with any of the spacecraft that are actively in the geostationary ring around Earth. But that graveyard orbit is effectively permanent, so it's not going to come back to Earth. These are objects which will stay there ad infinitum, basically, just like the planets. And that's because with the planets, they're not moving through an atmosphere. They are actually moving through the very outermost layers of the sun's atmosphere, but it's so rarefied that nothing slows them down. And so the planets stay in orbit perpetually, exactly as John says. So his question is right, is correct, but it's only the spacecraft in relatively low orbits out to, say, 1,000 kilometers or something like that will inevitably return back to Earth. And that's why there is a big problem with space junk, because there's all this stuff up there that, unless you can nudge it into a lower orbit, is going to stay put and be a hazard for future space exploration.
And pushing it further out probably isn't viable either, because some of this stuff's really small. And
it is.
And they've been experimenting with harpoons to try and get rid of some of these old satellites, and nets and all sorts of stuff. Yeah. And it continues to be a problem. And there was a case not so long ago that you and I talked about, where the International Space Station had to move because of a potential collision. And that's the other thing. Some of these craft that are orbiting do have power on board, so that they can maintain that 7.8 kilometers per second and don't have deteriorating orbits. So they can keep them up there longer than they would normally stay. Is that correct?
Yeah, that's right. Exactly. So the space station itself is it's exactly that scenario. It's big enough. Even though it's at a height of about 400 kilometers, it's big enough that it's got a fairly significant drag from the atmosphere, and about every 6 months it gets a boost to put it into a higher orbit. You can see all that plotted actually on some of the websites, the orbital maneuvers that they do.
Now, the other thing Judd mentioned was the moon. Now, this is an interesting scenario because it orbits Earth, but it is never going to fall back down to Earth, but it is in fact moving away.
That's right. It's going the other way. And that's because it's picking up energy from the Earth's rotation. If you give a satellite more energy, it goes into a higher orbit. That's just the way these things work. But paradoxically, it slows down. It goes into a higher orbit but slows down. So the moon is moving around the Earth at about 1 kilometre per second. But at the distance of the moon from the Earth, that's enough to give you this balance between gravity and the force that is pushing it outwards. So the slowdown of the moon is due to it paradoxically picking up energy from Earth. And of course, the other aspect of that is that the Earth's rotation is slowing down, which is why we need leap seconds every few years.
Yes, indeed. All right, Judd, I hope we helped you out with your question and covered every angle adequately. And thank you so much for sending it in. Fred, I've thought of a question, and I don't know whether to pose it now because I imagine it would take a while to answer, or whether we could save it up till next week. But we've talked many times about asteroids striking the Earth, and of course the dinosaur asteroid, and what impact a direct hit would have on the planet. But what impact would there be if an asteroid hit the moon instead of the Earth? What would be the impact on our planet?
It happens all the time, actually.
I'm talking about a big one.
Yeah, a big one is it was big ones that caused the cratering on the moon and those what we call lava basins, which they date back to the early years of the solar system. So these days we're talking about things a kilometre or so in diameter. If one of those hit the moon, it would be visible from Earth, if assuming it's on the side of the moon facing the Earth. But we know from seismometry left behind by the Apollo astronauts that things are hitting the moon all the time because there's no atmosphere to burn them up. So, even
it gets clobbered a lot.
Little rocks, things of that sort, things the size of a boulder hit the moon. Sometimes we see flashes on the moon, which come from events like that. They're called TLP, or transient lunar phenomena.
But I'm thinking like a dinosaur.
Yeah, a dinosaur killer. That's 15 kilometres across. We will probably know about one of those heading for the moon. We'd be able to watch it with great interest.
And what would happen?
There'd be a big flash. It's not, look, it would cause dramatic seismic effects. But remember, the moon is it's a quarter of the diameter of the Earth. It's over 3,000 kilometres in diameter. It's a big object, and something 15 kilometres is not going to knock it out of orbit or anything like that.
All right. Well, there you go. Didn't have to spend too much time on that one at all. My face was like the moon when I played football. It got hit all the time.
Yeah.
All right. Thank you, Fred. Always a pleasure.
Good to talk to you too, Andrew, and we'll speak again soon.
That's Fred Watson, astronomer, and he joins me every week on this podcast we like to call Space Nuts. We do welcome your feedback, whether it's something you've just seen or photographed and want to send us a picky, or if you have questions, we'll try to get to them all. They've been flooding in lately, so it's very hard, but we do really appreciate your input into our program, and we'll do our best for you. Until next week, thank you for listening to Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.